every time we do a proof, we rewrite out the question and draw the line. When looking at a question, probably, if you don't see any shortcuts, go to your main strategy, change things to sine and cos. So I can change cotangent to 1 over tangent, but in this case, I'm going to change cotangent to cos over sine. I'm going to use that strategy of changing everything to sines and cos and see what happens. This side too, cosecant would be 1 over sine, secant would be 1 over cos. And then I'm going to use the strategy of getting a single fraction. So the right-hand side, multiplying two fractions. Well, we multiply the tops. 1 times 1 is 1. Multiply the bottoms. And we get 1 over sine theta cos theta. That's a single fraction. On the left-hand side, I'm adding fractions. How do you add fractions? You need a common denominator. So this one would need to be multiplied by sine theta and sine theta, and this one by cos theta and cos theta. That would get my common denominator of sine theta cos theta. And in my numerator, I'm going to add them. I would get cos times cos, which is cos squared theta, and sine times sine is sine squared theta. And we're very close. We've got a single fraction on both sides. But now we're going to start looking for some of those other identities. And you know that sine squared plus cos squared is always equal to 1. So we get 1 over sine theta cos theta. Write our statement. Left side equals right side. And we're done. The second one. Again, you could do this by changing to sine over cos, but one of the strategies that we're going to start to look for and start to develop is the idea that if there's a relationship on both sides, like in this case, we have cotangent and cosecant. And I look on my formula sheet, and I see that cotangent squared plus 1 equals cosecant squared. I'll write that up at the top here. So on your formula sheet, you notice this. And what I would say, cotangent squared theta plus 1 equals cosecant squared theta. And I would recommend that all of your identities you have like mostly memorized. You shouldn't be doing a proof like this and not have in your head, hey, there's an identity that has cosecant squared and cotangent squared. I need to know that so that I have that as an idea. So in this question, before changing to sine and cos, because this one you can do a sine and cos, it just takes a half a page. If I notice something like, hey, I could take this cosecant squared right here and change it to cotangent squared theta plus 1. That might be a good advantage because then the only thing in this equation would be cotangents. What would that do? So I'm going to try it. I'm going to take this and instead of writing cosecant squared, I'm going to write cotangent squared theta plus 1. Then I can distribute this. Oh, and cotangent minus cotangent, that would go away and be 0. And I would just have cotangent cubed of theta. And I would be done. it was really short. So changing to sine and cos in this one might take us a long time, because we'll have lots of fractions that we're dealing with. Okay, not wrong, but what we want to start to realize is that often there's quicker ways if we get used to some of our other identities as well. And then we get into, I'm going to add a part C to this one. This question says, prove, this is a tough question, and it has powers of 4. So sometimes we have to use some of our other skills from algebra to solve, and one of those other skills that we have is factoring. Okay? In particular, I hope you can recognize quickly when you have a difference of squares. Difference of squares factoring, just a reminder, if I write it off to the side here, if you had an x squared minus 9, that factors nicely to be x plus 3, x minus 3. The difference of squares is 9 is 3 times 3, and x is x times x, and one would be positive and one would be negative as our factors. So what we have in our question is we have a difference of squares on this side. We have tan 4, which is tan squared and tan squared, secant to the 4, which is secant squared and secant squared, and one would be minus and one would be plus. The reason I'm not changing anything to sine and cos in this one is because I look at my formula sheet and I notice that there is the following. Tan squared theta plus 1 equals secant squared theta. So I can do one mental math manipulation here and say that tan squared theta would equal secant squared theta minus 1. If I take that in this first one, and can you see that if I change the tan squared to secant squared minus 1, and sometimes you have to visualize and think ahead a little bit. If I change the tan squared to secant squared minus 1, the secant squared and the secant squared would cancel out. That might be nice. Let's see what happens. So I change tan squared to secant squared theta minus 1, and then I still have minus secant squared theta, and this is still tan squared theta plus secant squared theta. And sure enough, secant squared minus secant squared would simplify, leaving me with just a minus 1. And with that minus 1 in that bracket, and if I distribute that minus 1, I would get negative tan squared minus secant squared. And we're done.